Okay, so for the next bit of this video, we're going to be looking at what happens as we take more and more approximations with more and more of these bars. So basically, if we have a curve that heads upwards, we're going to look at this curve a couple different ways. So for this kind of example, I'm going to talk to us about some left endpoint approximations. So let's say we have all of these. We start at, let's say, 1 here, and we go out to 3 here. And we start at 1 here, go out to 3 here, and we start at 1 here. We go out to 3 here. So if I only use 2 bars with the left endpoint approximation, I go up. That sets the height on my first bar. My second bar hits here. That sets the height on my second bar. If I look at the amount I'm missing, I'm undercounting by all of that. So that's undercounting by a pretty significant amount. So we would expect this approximation, since we're only using 2 bars, we'd expect it not to be great. If I go and use more bars, let's say we have, say in this one we use 4 bars. So we go up, we're doing a left endpoint approximation. Well, we're still undercounting, but since the bars are smaller, we're undercounting by a little bit less. We're missing some of the stuff there, we're missing some of the stuff there, missing there, and missing there. So if we increase to 4 bars, our approximation's a little bit better, getting a little bit closer. We're not undercounting by these massive chunks. There's more of them, but they're smaller in size. So if we go over to like 8 bars, which I may have trouble drawing 8 bars. So make sure 1, 2, 3, 4, 5, 6, 7, 8. So if we go over to do this, now there's going to be even more of these bars. And we are undercounting. It's a little hard to see the way that I've drawn these, but we are kind of undercounting, and since I hand drew them, there's going to be some issues. So each of these undercounts by a little bit there, a little bit there, a little bit there. So again, we get more. There's more sections, but the section sizes shrink. And if we compare this to the first one that we had here, we can see that even though there's more of these, there's 8 of these little undercounting parts, they're not adding up to as much area as we undercounted in this initial one. And so in general, as you include more bars, the approximation gets more accurate. So if I did 10,000 bars in there, I would be pretty close to the actual true area. And if I did 1,000,000 bars in between 1 and 3, that would be very, very close to what the actual area is. And that kind of leads us into this next theorem of the more bars you use, the more accurate your result is. So this theorem says if f of x is continuous on a to b, so we're continuous on a to b, then the endpoint, this means right endpoint and left endpoint, and midpoint approximations approach 1 and the same limit as n approaches infinity. Remember, n is the number of bars you break up into. So this one n was 2, this one n was 4, and that one n was 8. So these approach 1 and the same limit as the number of bars you use approach infinity. So in other words, there is a value L such that the following is true. The limit as n approaches infinity of the right endpoint approximation equals the limit as n approaches infinity of the left endpoint approximation equals the limit as n approaches infinity of the midpoint approximation, and they all would equal this value L. If the function is above the line, so if f of x is greater than or equal to 0, if it's above the x-axis the whole time, we define the area under the graph over a to b to BL. So as long as the function I'm dealing with stays above, so if here's the x-axis, as long as I'm looking at an interval where my function stays above the interval the whole time, if I use more and more bars, so I let the number of bars I'm using to approximate in between these, as that number approaches infinity, the area that's from calculating and adding all these bars together will converge to the true area under the curve over that interval. Now, if your curve does something like this, where it's, I don't know, kind of like that, and it goes above and below, we're going to handle that some differently, which we'll see in a couple sections. So for now, we're kind of worrying about area under curve, and you say, well, if it goes down here, is it a negative area, or what does that mean? So we'll hold off on that question of what happens as stuff goes below the x-axis. So we'll actually I'm gonna have to pause on this part here, and we'll finish it off here in a bit.